My name is Garrett Johnson. I am on the board of the Foundation for Florida's Future, which is a sister organization to the ExcelinEd Education Foundation. I am excited about this conversation. It's very, very important, but I often find that most people have no idea what to do with it, which is why you're probably in the room. So, three states come to mind in my opening remarks: Florida, Oxford, and California, or England and California. So I'm originally from Florida, which is where I met Jeb Bush, and I had no background in education policy before I interned in his administration my freshman year in college at Florida State. And then I went to grad school in England at Oxford, and one of my best friends happened to do his PhD in computer science. And then I came up with this idea based on my experience in education and working with my nephew's charter school that they needed a better way to communicate. But I wasn't technical, but I knew someone who was. And I convinced my best friend to create an application, create software for my nephew's charter school. And that turned into a different product in various iterations. But we applied to this program called Y Combinator, which moved me out to California, which is where I currently live. And now my career is focused on building technology companies. And so, like many of you, I don't write code. Like many of you, I have no plans to be a programmer in the future. But as all of you know, life is about experiences and exposure. And in an economy in a country where the cost of gaining access to technical education has plummeted, the cost of starting a company, launching your own startup has plummeted, we need to ensure, to empower every young person in America to be fluent, to have access to and exposure to coding and to technology. Not that everyone will be a coder or a programmer, or not that everyone will launch a startup or a tech company, but everyone will interact now or in the future to some extent with digital technology, either in their private lives or in their professional lives. And so transforming our educational system to ensure that students are empowered with the experience and with the exposure to technology that they need in order to pursue whatever dream that they have for themselves is going to be critically important. Either as a user, as a manager, or as a builder of technology, all of us are going to touch technology now or increasingly more in the future. So whether you are using technology to run a company or to perform your job either in education or in policy, all of you live on software, on productivity tools that make your job easier. And so we need a workforce that is competent and fluent with software and with technology. Whether you are managing technology in some IT-related role, software, data management, being fluent, understanding technology, being as technical as your role requires you to be, making sure that we have a workforce that's prepared for that is incredibly important. And then the last component that I see from my perspective of living in Silicon Valley, working with entrepreneurs, we want more people who are capable and have the ability to build the technology of the future. As I mentioned, the cost of creating a company, of launching a startup, is the lowest it's ever been. So pursuing bad ideas, the cost of pursuing bad ideas are cheaper than ever before. And in an environment where we are often scared by conversations of automation and artificial intelligence and other technologies that could lead to significant displacement in the short term and long term, we need to ensure that young people and anyone in the workforce, but especially those in the context of this conversation, K through 12, are empowered with either the skill sets or the relationships to be able to pursue some idea that could lead to gainful employment for themselves, a livelihood for their families, and make them builders of the technology that all of us could be using in our personal or professional lives. We have an amazing panel here, giants in this early movement to promote this concept of how do we transform our workforce to make them more technical, to increase their fluency with code. And so I'm going to introduce them using sort of an analogy that I often provide when speaking to young people. When you look at the NBA, the dream team of the NBA right now would probably include LeBron James, Steph Curry, Kevin Durant. You can name the 5 players that you would describe as being the dream team of the NBA. And when I talk to young people from low-income backgrounds, from minority backgrounds, who may not, be exposed to entrepreneurs, to people who are technical engineers or work in IT, I try to tell them that if you're looking for an opportunity for personal advancement, for career advancement, for social mobility, you often, see young people say, I want to be a professional athlete, a professional basketball player, football player, because that's what they're exposed to. But I asked them to consider the Facebook dream team, Mark Zuckerberg, Dustin Moskowitz, and others. And I, not that, what you make in your career, the net worth is an indicator, leading indicator of success, but, it's a good way to demonstrate the impact that you can have in one field versus the other. And when I tell the young people to add up the net worth of LeBron James, of, Steph Curry and others, and compare that to the network of a few people who built some software in a college dorm and scaled it to what we all now use and embrace as Facebook, the Facebook dream team, their net worth is almost 100 times more than Steph Curry and LeBron James. So being technical, being involved in technology, having a background where you are fluent in tech leads to opportunities. And so making sure that our young people are exposed to those options as they are to basketball and football and other opportunities that they are presented with in the sort of traditional framework of school that we have now is going to be really important. So keeping up with this theme of tech fluency and those being the superstars that we want our athletes to emulate and see as role models, I'm going to introduce each of the panelists who you all will be hearing from today. And after I introduce the last person on to my left, then we're going to have brief presentations by each of them so you can get a better understanding of who they are, what their backgrounds are, what their organizations do. We'll have a short moderated conversation. And then the most important part of this conversation happens when you come to the microphones and you ask the questions that are most important to you. So, starting with our first presenter, Hadi Partovi is the founder and CEO of Code.org. But most importantly, he is a graduate of Harvard University. And the mascot for Harvard University, I had no idea, is the Pilgrims. So Hadi Partovi will go first. Then Yuencia Ding is the Vice President of Opportunity at Work. She is a graduate of Northwestern University for her undergrad, and their mascot is Willie the Wildcat. Kevin Wang is the founder of Tails, has a long career in tech. He is a graduate of Cal Berkeley, and Oski the Bear is the mascot for Cal Berkeley. And last but not least, Anthony Owens is the State Director of Computer Science for the Arkansas Department of Education. His undergrad was at Henderson State University, and they are home of the Reddies. So please, in that order, our dream team for today, please welcome Hadi Partovi. Thank you.
I don't know if it's changed, but actually when I was at Harvard, the official mascot wasn't the Pilgrims, it was the color crimson, which was a color. I don't even know how you have a mascot that is a color.
The original mascot was the
Was
Pilgrims,
the
then
yeah.
switched to the Crimson.
Well, when I was there, I was like, go the color. You know, it's very difficult to cheer for the team. Anyway, I wanted to really briefly talk about the vision behind code.org and why we care so much about computer science. Our vision is that every student in every school should have the opportunity to learn computer science. And we're called code.org, but computer science is broader than just coding. It includes data science, machine learning, networking, robotics, cybersecurity, and it's something that touches all fields of not just academic learning, but every industry. Now, there's 3 reasons why teaching computer science in schools is important. The first one, which doesn't even need talking about, is that it leads to the economic opportunity and the best careers. The highest paying, fastest growing, and now largest sector of all new wages in the country are in computing in every single state and in every industry. But that's the reason everybody talks about is career growth or economic growth jobs and career-ready jobs. The second reason to teach computer science is because it's foundational for every child, no matter what career they want to go into. And then the third reason, which is what people don't talk about at all, is that it can help make school fun again, which is actually, for me, the most important reason. So I want to show one slide for each of number 2 and number 3. In terms of making computer science, why it's foundational, everybody in this room, when you went to school, learned about the internals of the digestive system, or how electricity turns on a light bulb, or how a squared plus b squared equals c squared. It's just part of the understanding that if you're a well-rounded, educated person, anywhere in the world you learn these things. In the 21st century, it's just as important to learn what's an algorithm, or how does the internet work. You expect that your lawyer, if you have a lawyer, they learned biology when they went to school. If you have a doctor, they learned something about electricity or math when they went to school. We should all, no matter what career we go into, also learn a bit of computer science. And our students actually want this much more than we imagine. As adults, we think, oh, our students don't want to learn it. If you actually survey students, and we didn't run this survey, an outside group, Change the Equation, did it, asking students what subjects do they like a lot. Right after art and design and performing arts, dance and music, computer science was number 3 in terms of what they want the most. When you consider that it leads to the best paying jobs, it's foundational for every career, and our students like it so much, why aren't we teaching this in every school? So this isn't just an idea or an opportunity without results. We have the amazing fortune to be spearheading what has become a global teacher-led movement to change the curriculum, not just in this country, but because of the leadership of this country and the entire world. This is my favorite slide. It's basically, this shows what's happened in the 4 years since code.org came on the scene. In just 4 years, over 120 school districts have embraced computer science, including all of the largest school districts in the country, basically saying this has got to be a field that goes in every school. Next week, we're about to announce 70 more school districts joining them all in one day. Actually, this slide is out of date, it just changed in the last month. 65,000 teachers have attended workshops to begin teaching computer science. Over 1/4 of all the students in the United States have begun coding, and that's just on the code.org platform. We've been around for 4 years. 1 out of 4 students in the entire country has started using code.org. There's other coding platforms that are also popular. 31 states have changed policies in some fashion and begun embracing computer science. And then because of the leadership America is showing, which is kind of rare to have America leading education for the rest of the world, but 13 countries have changed curriculum to add computer science to part of their national curriculum, supported with over $1 billion in funding for that. This is an unprecedented level of change in the education system to cope with something that's just innate. We all recognize technology is changing the world, and we should be teaching it in our education system. So, and this really is thanks to America's educators. This is something that has happened because of the uptake starting from individual teachers in classrooms deciding that this is important for their kids. So I want to close on just one graph. This is the chart of students taking AP Computer Science, which is the fastest growing AP course in the history of the College Board. On the left is girls taking AP Computer Science, and on the right is underrepresented minorities taking AP Computer Science. What you see in the 2017 bar, a new AP course got launched, causing a lot of growth, and that's also the first year that code.org's classrooms began teaching AP Computer Science, and those two things compounded to create a huge amount of growth. This is awesome. This is a field that does not have a lot of girls in it. It's a field that is predominantly white and Asian upper middle class boys or men. And to have America's schools create graphs like that should warm all of our hearts about what's possible through education if you give access to every child. Thank you.
Thank you, Hadi. So at Opportunity at Work, we often have a little motto that is called skills, not degrees. So rather than focus on my Northwestern credentials, I'm going to reveal a little known fact about myself, which is that when I was 11 years old, while all the other kids got sent to regular summer camp, I got sent to Pascal camp. Pascal, for anybody who doesn't know what it is, was like a computer science language developed in the 70s that I don't think anyone uses anymore, I'd hope. So, look, when we think about tech at Opportunity at Work, we don't actually mean it in terms of an industry. We don't mean it in terms of a sector. It's not just about Facebook and Amazon and sexy companies. It is a set of roles and a set of jobs. It is every hospital that needs an IT support person. It is every retailer that needs a database administrator. There are millions of tech jobs out there. And in fact, by 2020, there are going to be 1.4 million computing jobs in the US based on current growth rates, and only 400,000 people graduating from colleges and universities with a computer science degree. So that means that if companies continue to only look for people with a 4-year degree in computer science, we're looking at 1 million jobs that will go unfilled in the American economy because we're not looking for skills, we're looking for degrees. What that leads to is, one, the fact that already 15% of tech jobs, or 15% of open jobs out there are tech related, and because there are not enough people with these credentials and with these degrees, those jobs pay 50% above average salary. So when we think about being inclusive, when we think about making this welcoming and diverse population of people that can be part of this, it isn't just to help them, it is giving them access to something that's upwardly mobile, giving them access to something that is economic opportunity, not just for themselves, but for their families and for their children. As a result of this tremendous need and demand that's been signaled in the marketplace, we've seen the rise of a ton of education and training programs and providers that are trying to fill this need. So between 2014 and 2015, for example, the number of coding boot camps that existed in the marketplace grew by 240%. And if you all are following, this year, we started to see some consolidation, we've started to see some closures. So the way that the supplier market, the way that the education market is responding to this need for more people and talented individuals with these skills is, frankly, right now, very fast, very quick, and very haphazard. So at Opportunity at Work, when we think about this problem, we think about not as just a demand and supply problem, but really as a demand and demand problem. And what I mean by that is there are companies that have a demand for tech workers, for people with the skills to do the jobs. And we also know that on the other side, there are actual individual humans, the students that we are all here to serve, the skill seekers, the job seekers, the people who are actually trying to get meaningful, productive, fulfilling work. Their demand for that work is the other side of this equation. And what we do, what most of us in this room and most of us who have worked in education for a long time do, is sit in the middle between those two demands. That's our role. And no matter how hard we work, frankly, the real work is done by those students, by those skill seekers who show up every day and just want to take advantage of the opportunities that are made available to them. So part of the problem, and you heard Governor Bush talk about this a little bit this morning, is the rigidity and the linearity and the leakiness of the current path to upwardly mobile jobs. So what I mean by that is, right now, the way to get into a good job is you hopefully get into school as early as maybe the age of 3 if you get access to a good early childhood education. If not, at 5, you do hopefully well in elementary school, you hopefully do well in middle school, high school, get into a good college, graduate from a good college, get into a good entry-level first job. if you come off the track at any point along that path, if you don't do well in middle school, if you drop out of high school, if you don't get into college, or if you don't do well in college, if you don't get that first job, it is hard to get back on. It is hard to get back into a path where you are upwardly mobile, where you are on track to get that middle class job, and we know that that is the case, and that is what we're trying to ultimately break down. So Opportunity at Work does a few different things. We, for example, first have an online inclusive hiring marketplace called techhire.careers, where people can go, regardless of what your resume says, regardless of what age you are, you can basically take a technical assessment and a soft skills assessment, and if you pass both, wind up on a candidate board, not a job board, but a candidate board, and be showcased to employers for having validated your skills. Skipping to the third, we also work in talent financing. And what that is really thinking about how do we make some of these new education and training opportunities more accessible and available to students in a way that doesn't strap a backpack full of debt on their back and say, go off, we hope you find a job after you're done, but actually incentivizes the education and training providers to have skin in the game, to really do this in an outcomes-oriented way with taking employers in mind and thinking about where their students are going to be after they finish. And the last thing that we currently manage right now is the Tech Hire Communities. So Tech Hire Communities is a local place-based movement launched by the Obama White House that now includes 70 communities all over the United States, where some combination of companies, employers, education and training providers, local community-based organizations, and civic institutions have raised their hand and said, we know this is a problem, we want to fix it, we want to work with others to fix it. That's what Tech Hire is all about, and there's obviously a few examples listed here. There's one in particular that I want to call out, which is Rhode Island, which is our learning lab. So we have staff on the ground in Rhode Island working with the state on an initiative called Computer Science for Rhode Island, supported very much by Governor Gina Raimondo, which is really trying to make sure that Rhode Island has coding in every single K-12 public school. So we're very proud of that work. In other Tech Hire communities, we're really proud to be learning from the education and training providers and the civic institutions and the community-based organizations that do the work, including many of the ones that you see on the slide. So with that, I'm going to pause, but the one thing I will say is throughout the course of the day today, in all of the panels and all of the discussions that I've heard, I'm so encouraged by the fact that we are not just talking about this anymore as a K-12. We're not saying we start at the age of 5 and we end at the age of 18. That is, for many of us who have been in the education reform movement, a lot of what our focus has been. I've heard a lot about jobs. I've heard a lot about higher ed. I've heard a lot about post-secondary. And I'm really encouraged by that because it can't just be K-12. You know, we have to make sure that this path works all the way from cradle to career. And in order to do that, we have to expand beyond what we think is our locus of control, what we think are the boundaries of and scope of our roles, and really think about what is it our students need, not just from us, but from the next person that they're going to be, in the next institution they're going to be a part of. And so very, very excited to be part of this conversation, and thank you very much for having me here.
Hi there, my name is Kevin, and I'm the founder of the TEALS program, which is now part of Microsoft Philanthropies. And we've been really concentrating on computer science teacher capacity building for the past 9 years now. You know, we can, you know, as we talk about computer science and need to teach it, the most important thing that we actually need are the teachers who are in front of our kids day in and day out, and we simply don't have enough computer science classroom teachers. They don't currently exist. So how do we build that teacher capacity so we can actually have awesome teachers for our for our students. And usually, especially at the high school level, what you get is, as a classroom teacher, is that your principal, your district administrator, talk to somebody at the state level and say, well, yeah, we're doing computer science now, guys, and we want your school or your district to have it. And so it kind of filters down, all the way down to the classroom teacher. And I'm not sure if any of you heard that expression, but some teachers get voluntold that they're going to be teaching computer science next year. And as a principal, they say, hey, you know what? We know it's a new subject for you. I'm now going to send you to teacher training for a week. And there you go, right? And that's kind of what's been happening for quite a few years now. But imagine if imagine if now, let's say, Napoleon takes over the world and French is now the language to learn. There's a lot of French textbooks out there, not enough French speakers out there. What we need for, if we want to teach French is have a lot of capable French speakers teaching AP French in our high schools. And you can't learn that in a week. And it's very, very difficult, especially for someone who's new to the subject. So what TEALS does is that we have software engineers. We have relatively flexible work schedules. Most of us don't go to work until probably 10 or possibly even later. And we have software engineers essentially do pro bono teaching with an existing classroom teacher. We pair trained software engineers. We recruit and train them, and they teach a period of computer science, high school computer science, with an existing classroom teacher, math teacher, science teacher, English teacher, art teachers, whoever wants to teach computer science. And over the course of a year or two, they teach enough, or they learn alongside with the kids, and then they slowly take over and eventually teach enough computer science, and they can teach computer science on their own. Essentially, that's essentially the basis of what we do. And over the past 5-6 years, we've been also expanding to rural areas. We realize rural areas don't have that kind of access sort of for software engineers. So what we actually do is we've been working with rural schools and go using Skype for Business. We try to replicate our program that we do in person. So we've been doing quite a bit. We have very close by high school in eastern Kentucky. The classroom teacher now teaches on her own and sent students, I think, very close by to Vanderbilt, and he's got offers from Home Depot and Capital One and quite a few other places for internships, not necessarily Amazon, Facebook, and Google, but you can imagine there's a lot of these jobs all around the country. We believe in absolutely rigorous computer science, and so our curriculum we take from Berkeley and University of Washington, as well as APCS principals curriculum from Code.org, from NIMSY, from Project Lead the Way, and quite a few other curriculum partners, because everyone has very different needs, so we try to go ahead and meet all of those. And of course, it's almost like we planned it. There's a sports analogy. This is a teacher. I think he's a baseball coach and teacher we've been working with in Central Washington. He essentially said, what he described TEALS is if you're coaching a sport, you had a Major League Baseball player coming in to coach your team, and that's what it really, really is. And our applications for schools are open. It's going to close in February. And so, folks want to partner and start something in your state or a county or city or district, let us know. And it's a true partnership process. Our organization recruits, trains volunteers. We also work with your classroom teacher. We visit your schools, get feedback, and so it's a really hands-on, in-depth, end-to-end thing. But then also we partner with the school, the district, the community all together as well. So it's really a partnership to make all of this work. So there you go, sir, and here's Anthony.
Thank you, Kevin. Well, I'm going to start, and first of all, I can't believe nobody up here on the stage said that next week is Computer Science Education Week. We need to remind everybody of that. So next week there are over 110,000 hour of code events scheduled around the world. Primarily, a lot of those are here in the U.S. So if you want to see why you need to make computer science a priority, go to one of those family code nights, go to one of those hour of code events, and watch those children show their parents My son got to work with the Commissioner of Education in Arkansas and help him through his hour of code, his first hour of code. But go watch those kids engage in that work. And I just want to take a point of personal preference and thank Hadi. You know, there is probably not any more influential person in this space than Hadi. You know, there have been over 100 million students that have engaged with the Hour of Code, and that's over 450 million completed hours. And just code.org and their work that they've done just nationally is just phenomenal, and a lot of that's because of Hadi's personal passion for this space. And I know Arkansas would not be where it is without the support of code.org. So thank you, Hadi and code.org. Yes, definitely. Give him a hand. To that point, I'll spend a little bit of time bragging on our state. The people ask, how do you get something like this to happen in our state? And I tell them, well, you find a governor and you get their granddaughter to write an app and show them, hey, Pawpaw, look what I did, because that's how it started in Arkansas. And I'm not lying. Governor Hutchinson's daughter, our granddaughter, when he was running for office, showed him an app that she had created and some work that she had done through the code.org Hour of Code. And he said, why are they not all doing this? If my 11-year-old granddaughter can do this, this is something we should be rolling out to all of our students. So he made it a focus of his campaign, made it a promise. And like a lot of other campaign promises, there were a lot of people that thought it was just empty rhetoric. He was elected, and I can tell you, it was not empty rhetoric. He doubled down on it within his administration. Within the first few months, he worked with the legislature to pass the first comprehensive legislation requiring every high school in the state of Arkansas to offer computer science. He worked with our State Board of Education to redefine our flex credit. He charged our offices with developing comprehensive standards, and I'll get into that a little bit. But obviously, you know, our state has grown to prominence nationally. And in fact, this is an old slide. Facebook donation now has grown to about $3 million of technology going directly to our schools. We're recognized by code.org, we're recognized by Microsoft, just large players seeing our initiative and the success that it has already had and the potential future growth. We were the first, and we are still the only state to meet all 9 of code.org's policy ideas. Bank of New York Mellon, I was so pleased this morning in another session to hear a gentleman speaking about computer coding is not just creating additional programmers. And that's really the focus that we have in our state. And so I love this report out by Bank of New York Mellon. And everybody asks, why in the world would a bank care about computer science? Well, of course, they have computer programmers and they should be interested in cybersecurity. But the VP that presented this report, he said that's not why. He said it is because investment bankers, we will no longer hire an investment banker unless they have a background in computer science. Arkansas was the only state, and still the only state, to meet all 10 priority suggestions that they had. I'm not going to read this slide to you. All these materials are available. I have them on my website, and they're available. But really, we have our own list of reasons of why we think we were successful early on, and that came down to that legislation and building out comprehensive standards K through 12. And by the way, we built those out with our career education department. So if you're going to ask the question of, is computer science academic or career tech in Arkansas? The answer is yes. We see no difference. Same teachers can teach it. It's the same credit no matter who teaches it. And there's not special course codes. There's not different course codes depending on the area. Creating an essential point of contact. My mother taught me at an early age, no matter how good you are at something, there's always someone who can do it better. So when I talk about this, I'm not talking about me, but we were the first state to create a central point of contact dedicated 100% to computer science. I just was very blessed to be able to serve Arkansas and Governor Hutchinson as that point of contact. But if your state is interested and truly dedicated to having CS as a focus, that is a crucial part. Graduation credit, or CS Flex credit, is held up by code.org as a national model. I can share more on that in a little bit. And Kevin hit the nail on the head. Any state that is looking at implementing a CS program, a CS initiative statewide, the biggest obstacle is going to be teacher capacity. And in that does not just mean the raw number of teachers, as Kevin was speaking, but as Kevin spoke to, it's also the content knowledge of the teachers that you have out there in the field teaching this subject area. It's going to continue to grow. I have a math background, and math has not changed much in 400 years. Computer science has changed quite a bit in the past 4 days. So obviously that increased teacher capacity and continued building. Funding, Arkansas is just extremely lucky in our funding, and we've put a sizable public commitment behind our CS education, in fact the largest in the nation. And yes, that's not the largest of any state of similar size, it's the largest in the nation. But because of our public funding commitments, we have been able to leverage that into getting private dollars poured into our state because they see our state putting our own money behind it and saying we see this as a priority, so they're more willing to step up. Our strategic plan for computer science is available online. We have a couple states that have adopted it and just struck out Arkansas and wrote in their state name, and by all means, please do so. We're pleased to share. We don't even call it stealing, we just share. But this is kind of a graphic that hits the high points of it. We just came out of phase 1, which was getting that legislation, regulation, our standards and courses, and initiative promotion, promoting the initiative early on. We were able to grow from about 1,100 students taking a high quality computer science. And yes, we don't agree. We love Word and we love typing, but that's not computer science in our state either. About 1,100 students the year before Governor Hutchinson took office to last year was 5,500 students. And I won't steal his thunder because he's going to announce this year's numbers next week, but I can tell you we saw another sizable growth for this current school year. We're currently in phase 2. We're going to continue focusing on expanding teacher capacity. The vast majority of our funding is going to that state level funding. And that's at the direction of Governor Hutchinson because he knows that's crucial, and so do we. Promoting not just general enrollment, but diversity of enrollment. We think that our K-8 plan is going to really change the paradigm when it comes to that diversity piece at a high school level down the road. Post-secondary alignment, a lot of states aren't to this discussion yet, but if you're really implementing computer science at the K-12 level like it should be, what does your post-secondary programs look like? Not just your teacher prep programs, your teacher pre-service programs, but those computer science major programs. And then we're going to continue to evaluate and change as we need. This is kind of a motto of my office. I came from a corporate background, and I'm also a lawyer by trade. So my office, we operate under the no excuses, only actions motto, and I guess we're just keeping with the sports analogies. I guess you can call it sports. It was Arnold Schwarzenegger that said, you can have results or excuses, not both, and that's how we live in our office. So, thank you.
So we're going to have a little bit of Q&A with the panel, but then we want to take questions from you. So please start thinking about those questions and get ready. So, Hadi, the vast majority of people who take a cool.org class will not become a programmer. The vast majority of people will interact with productivity tools, Google Docs, Slack, Microsoft Office, whatever the case may be. So why is it an emphasis on promoting access to coding in schools as opposed to what you mentioned of teaching other productivity, technology skills? Why is the focus on code?
So first of all, our focus is broader than coding. It's coding and computer science. The reason we call ourselves code.org is when you talk to a school about computer science, they say, oh, computer science, yeah, we teach typing, and we bought a bunch of iPads, and they don't realize that computer science is actually an academic field that involves lots of other things. When you talk about coding, they're like, oh, we don't do that. But coding is only part of computer science. Things like data analysis, cybersecurity, networking, these are all parts of the field. And the reason for every child to learn that isn't because every one of them is going to become a network analyst or every one of them is going to become a coder. It's because every one of them is going to live in a world where this stuff is all around us and touches and impacts every part of our lives. Now, we also support teaching digital skills such as typing, but we increasingly see that students learn those things playing Minecraft, most students are learning how to type. Using Snapchat, kids are learning how to type. And it's actually not even clear that typing is going to be a thing in 20 years, the way voice recognition is working. So the people who create the applications that we use are making them easier and easier and easier to use, to the point that learning how to use those apps has become less really learning. It's just you pick it up and you go. And the type of learning that's most important is understanding how this technology is working and being prepared to adapt with the technology.
So, quick question for the audience. How many people in the room are programmers, actually write code? All right, so we have 1, 2, 3. Okay, so how many people have an immediate friend, someone that you can pick up the phone and call right now, family member or a friend who is a programmer or an engineer? Okay, so quite a few people. All right, how many people in here have a 4-year degree? Okay, so the majority of people, this is for you, Usana, Uncia. So this question is for you. You know, the question of how do we get out of the mindset of everyone has to go through a 4-year program in order to be eligible for some type of technical job. You know, everyone, or the majority of people in the room, you know, went through that track of having a 4-year at least a 4-year training in an institution of higher education. These are the people who are teaching. These are the people who are hiring. You know, they are the decision makers in the workforce at present. So how are you changing the way that these people think about what are the requirements for technical roles? How are you guys doing that on a day-to-day basis?
Yeah, it's a really good question. So look, I'd actually love to ask the audience as well. So who here considers themselves an educator? All right, so I do too. And the reason for that is because, you know, I have over the past, you know, couple decades worked on the management staff of Teach for America. I have been a charter school supporter. I'm the proud board member of a school called DC International Public Charter School in Washington, DC. I was in President Obama's U.S. Department of Education, working on higher ed policy, and I consider myself an educator and am proud to be one of you as a result of all of that. But when I think about what I said at the beginning, which is the demand versus the demand, the companies on the one end and our students on the other, we in education tend to start, and remain focused on the middle. And the difference, and what I really want us to all be thinking differently, is to remember that while the middle is important, the middle should come third. And what I mean by that is, first, that our students come first, right? Like, I think we can all agree on that. Students should come first. Second, though, is this has been a huge change in my thinking over the past year, is that it is not just about shoving students through the funnel that we have all been through. It is about looking to the end of that funnel and saying, are there companies that are willing, that are able, that are ready to give our students, to give talented people, regardless of their race, gender, socioeconomic status, sexual orientation, or anything else, a chance, even when that person doesn't have the resume that we do, doesn't look like us, doesn't feel like us, doesn't have the credentials or the degree or anything similar to us? Do they have the skills? Do they have the technical skills? Do they have the soft skills? That's why while our students have to come first, I believe the end, the outcome, the job for them, their ultimate career trajectory, that has to come second. And that means that our work as educators has to come third. It is important work. It is profoundly hard work to do well, frankly. But when I think about the mindset shift that we all need to make, it's about remembering that as educators, we are in the middle between demand and demand.
So,
I by the way have a different answer to that question you asked. Is a 4-year degree necessary? In the field of computer science, has the world's most famous college dropouts. And if you had to pick what is the one field, if you got good at this, that you wouldn't need a 4-year degree, you could literally become the world's wealthiest man, or now second wealthiest or whatever, it is computer science, because if you learn the skills, frankly, employers don't care nearly as much in this field whether you have the degree. They care about whether you can do the work.
So, I agree with that point, but I think it's very much regional. At least that's been my experience recently. So I'm from Tampa, Florida. You have a lot of interesting things happening in the city. They're trying to become more of a tech hub. You have some organizations, nonprofits, who are trying to provide coding training, for people who are either in K-12 or who exited, higher education, maybe with a GED. They didn't get a 4-year degree. They need some type of technical training. And the feedback that I got, because I mentioned, why aren't you focusing on nano degrees and partnering with Coursera or Udacity to get these type of certifications? And they make clear to me in talking with their corporate partners on the ground in Tampa that they want 4-year degree graduates for technical roles. That's what they're looking for. And I drive up and down 101 in the Bay Area, and I see all the signs for all the nano degrees and all these certifications, and that makes sense in Silicon Valley, but it seems not to be the case in other parts of the country.
They want 4-year computer science degrees. Mm-hmm. And that's not what most of our institutions do. Most of our institutions of higher ed are producing all sorts of different types of degrees. It turns out actually that a 2-year computer science degree from a community college, from almost any community college, has a higher return on investment than a 4-year degree from Harvard, which I went to in a liberal arts. And that's not because Harvard is bad or that liberal arts are bad, but actually of course a computer science degree from Harvard is the best you could get, better than I'm kidding. But I'm a big fan of 4-year degrees, but I'm an even bigger fan of learning the skills that the job market wants. And you can, with even a 2-year degree in computer science, get a great paying job.
I think you bring up a really good point, Garrett, that a lot of companies and employers aren't there yet. And we spend a lot of time getting them there. We spend a lot of effort getting them there. And I think, it depends on every company for sure, sort of where they are in the realization that this is going to have to change, because this can be many years of talking to HR managers, of trying to convince them that they can take a chance on somebody who doesn't have a 4-year degree, that they can. The 4-year degree it's almost a little bit like what the people used to say about IBM, like you can't get fired for hiring IBM, right? Like that's like the 4-year degree. At some point you get over that because you realize that you still need somebody with the skills, and it is really hard to find that. Not when you leave Silicon Valley, when you leave New York, when you leave the big cities, it is hard to find tech talent. Frankly, I think it's hard to find tech talent these days in Silicon Valley from what I hear. So if you define tech talent as only people who have a certain set of things on their resume, as a company, what we're hearing more and more these days from CEOs is that the talent gap that they feel is becoming urgent, it's becoming desperate, and it's becoming a real business problem. And so you're right, not every company is there, certainly not every HR manager is there, but a lot of them are getting there, and particularly at the C-level, we're sensing that change pretty quickly these days.
Kevin, you have this sense in the country that there is a skepticism about tech and how it's impacting our country. Facebook and Twitter, they're ruining our democracy. Uber and Amazon, they're taking all of our jobs. So my question to you, because you focus on bringing engineers into the classroom, so what do you see as the role of the tech industry specifically, but industry in general, and helping to provide K-12 education with the skill set that it needs to make sure that we are providing these types of opportunities to young people?
Yeah, I think the tech industry, is in an interesting position. I think we just talked about jobs, right? They need the talent to continue to innovate, and we want to make sure that continues to happen. But increasingly, like Anthony said, it's not just the tech, and it's not just the Facebooks, the Amazons that are hiring and the Microsofts are hiring the software engineers. It's increasingly the John Deeres, the Johnson Controls, every other industry, in order to not just to go into new business sector, but to just survive, to be able to compete. Just like what Dr. Christensen showed us, that is now AI, machine learning, that is now increasingly a part of just how you do business to give you that competitive edge. It's a necessity rather than something that's like, oh, it's nice to have, we'll go look at it later kind of thing. And I think for tech companies, we've been, I think, saying, certain platforms. As engineers, engineering is always the solution to anything in the world. Legislators think legislation is the answer to a lot of things in the world. And so we build a lot of, tools and things, but ultimately, I think, teacher capacity, how we teach our next generation is the most important part. And we do what we can with that pro bono work our TEALS volunteers do and a lot of other companies do. And it's evolved from like a one-day engagement, like bring your career days where you have somebody, a fireman, a pilot, a doctor, an engineer, and you do that 1 hour talk for class, and it's like, who does that really benefit? At the end of the day, you actually, the engineers who go in, it makes them feel better about themselves and what they've done, but doesn't really impact the students, right? They saw somebody, just like a NBA player comes talk about what their job is. Does that mean you're going to play more basketball? No, that's so out of reach, right? And so having that sustained engagement with the education sector in a partnership where we respect each other's profession and what we do and what we both bring to the table is incredibly important. Having that partnership, it's such a huge problem that needs everybody really to pitch in. And it's, and all of these jobs, it's going to be in some other discipline. Your area of expertise is going to be in some other area, whether it's agriculture, whether it's medicine, whether it's sports management. But you need to have computer science to do those jobs. And as well as, I think fundamentally as a democracy, the cornerstone of a democracy is an informed citizenry. That's why Benjamin Franklin, invented the post office. It's not to deliver Amazon packages. It is to deliver newspapers and make sure, the citizens of this country are informed. And we can't just look at our students and say, well, this computer science, all this stuff that you use is, it's just magic. Someone else made it, and just call it a day, right? We simply cannot do that. We owe our kids much, much more than that. So we need to teach them, just like biology, physics, anything else, English, journalism, a fundamental understanding, high school, newspaper reading, understanding what's actually going underneath. So when they read something in the paper, it's not magic, but it's something that they at least have a high school understanding of. And that builds a foundation for whatever they want to do, 2-year, 4-year, just like biology, right? We teach biology not because everyone's going to be become a doctor, but they have options. With that biology class, you have so many options. Yeah, you want to be an EMT? Great, you do that 8-month training course. You want to be a nurse? Great, you do the 2-year course. You want to be an oceanographer? Great, you do the 4-year thing. If you want to be a cancer researcher, PhD time. If you want to be a doctor and operate on people, well, med school. It's the foundation for them to do whatever they want to do in that field or outside of that field. But it is fundamental and it is important, and it's going to be something that your students in whichever state you're from and this country really, really needs. Every other country has seen that and are investing heavily, and we need to do the same in our teachers, in our schools, and in our students.
Anthony, I'm coming to you. We'll be ready for questions shortly, so please start to think of your questions. So, Hadi had a slide to demonstrate that there's clear demand among all students, women, minorities. There's a real demand. So how do you ensure equity of access? Arkansas has a lot of rural communities, low-income communities. Talk to me about how you guys have managed that.
Well, the first thing that as a nation we have to address, and Arkansas luckily has addressed this, is just the access issue. Last statistics available via code.org is still we're approximately 1 in 4 schools, 1 in 4 high schools across the nation make available to their students a computer science course. Well, you can't talk about equity until you fix the access problem. I mean, there's really no reason to have that discussion. But now that in Arkansas we have addressed the access issue, there are other things that have to be in place. You need to make sure that your courses are approachable by multiple entities. So that's one reason that APCS Principles was so successful in its first year, is that it is an approachable curriculum. It does not need to be a coding-centric curriculum early on. It really has to get to the basis and the overall arching concepts of computer science. The other thing is what I alluded to earlier, and what we really see as our long-term key to closing that gender and underserved population gap in Arkansas, is that we developed and have adopted and implemented statewide K-8 embedded computer science standards. So we want every teacher talking about, from K through 8th grade, to every student about how computer science relates to their content area. It's not every teacher teaching a kid to program in C++, but you show me a math teacher in 2nd grade who is not teaching algorithms. They may not call it algorithms, but you show me a teacher in 2nd grade, math teacher, that's not teaching algorithms, and I'll show you a teacher that needs to go to the house. So it's using those terms, it's using that technology that is relatable to computer science, because those K-8 teachers are so, if you think about and you look at the statistics nationally, not only are the teachers at a K-8 level predominantly female, which is one of our big issues in the gap, they also are more reflective of the racial and ethnic demographics of the communities that they serve within. So you have little Susie seeing Miss Smith talk about algorithms who looks like her, who is a female like her, and then by the time little Susie makes it to high school, computer science is not something weird. Computer science is something that she's been doing for 8 years, and yes, it's approachable by them. The other issues, we will have people make excuses and say, well, rural areas don't have access to broadband internet. Arkansas, luckily, we fixed that. But they don't have access to the greatest technology. How many students walk around nowadays that do not have one of these devices or some sort of one of these smartphones? And if you think about this smartphone, it is thousands of times more powerful than we as a nation put men on the moon and brought them back with. To say our kids don't have access to technology is an excuse, and I don't accept it.
Questions? Any questions? Please.
Hi, so computer science is for all kids. You have policymakers sitting in this room. I would love to hear from the panelists. What's an action step we can take to support computer science visions in our communities?
I'd love to answer that one. First of all, if you visit code.org, there's plenty of materials on our site for states specifically on that, and we publish 9 ideas, which Anthony was proud to say Arkansas was the first state to do all 9 of them. The most important idea is to set a stake in the ground that every school should teach computer science, and then work backwards from there. And then the things that you work backwards from, one of the first things you find is a shortage of teachers, which means you'll need funding for training existing teachers to teach computer science. That's probably the single most important part. But then the other things are establishing computer science standards, establishing teacher certification rules, making sure computer science counts for graduation, making sure that you have a state staff member in charge of the computer science program, just like Anthony. If you're lucky, you might actually get Anthony. But if you can try to get somebody as good as him. And there's a bunch of others to lead up to those 9 ideas. But the first is setting the stake in the ground of teaching computer science in every school, and then training the teachers. The funding to train new computer science teachers is one of the best investments a state can make. Every state in this country has more jobs in computing than it has graduates, and it's a 5-to-1 or 10-to-1 ratio. And the open jobs, the currently open jobs in every state, the salaries alone from those are usually 100 times more in terms of the dollars than the cost it would take to train enough teachers to create a pipeline of students to fill those jobs. And the stats, if you go to code.org, if you click on our button for stats, pick any state, whatever state you're in, and we actually will give you a printout of how many the open jobs are, how much the current salaries are, the graduates. It actually makes the economic case at code.org for your state and the policy ideas. So go to code.org and click stats, and you can get your answer.
Kevin, did you have something on that, or?
Yeah, definitely. I would just like to echo the all of the policy work and the standards, but the teacher capacity, the short term, it's your in-service teachers, right? I think someone asked, hey, why don't we just get all the engineers and make them go teach? You can go and try it and see if you can make that. There's 45,000 high schools in the U.S. So, and you heard how many high school or college undergrads we graduate every year. So it's very much a teacher capacity issue. So in the short term, in-service teachers, figure out how you can fund teacher PD and find the right program for you, and figure out how you could get in-service teachers to teach computer science at all grade levels. But the longer term, right? The longer term strategy is making sure your state, whatever your state's biggest teacher college is, right? Make sure that the pre-service teachers, if they're getting a math certificate, a science certificate, make sure that they take a couple of college intro CS classes while they're there. So they come out, they can teach computer science from the get-go. So 2 phases, train current in-service teachers, and make sure whatever institutions that you have that trains pre-service teachers, make sure computer science is a part of their certification program.
We've got time for a few more questions. Here, please.
Hi, I'm Jillian Balo. I'm the state superintendent in Wyoming, and I was wondering if you might just address the concept or notion that some states are talking about regarding coding taking the place of a foreign language.
So I'm happy to take that. So as I mentioned, I'm on the board of a school called DC International Public Charter School. It is the only and the largest middle and high school where all the language immersion schools in the DC area feed into our school. So it's 800 students, and it's really exciting. I very deeply, personally, and spend a lot of time thinking about the need for multilingualism in the 21st century economy. I think it's a hugely important piece. It is just as important, I would say, as the technical skills that we're talking about here. It is just as important as math and reading. At DCI, we do focus on language, but we also are a Google Classroom demonstration site. That means that all of our students get Chromebooks, that they have the opportunity to learn Scratch, HTML, Python, web design. We have classes on ethics and of internet usage, hacking, and privacy. We have AP computer science classes, and we even offer certifications like IC3 and CompTIA A+, in addition to our International Baccalaureate curriculum. So I reject entirely any notion that one needs to replace the other, because in order for our students to have what they need to be able to be competitive in the global economy in the 21st century, they're going to have both.
There's a challenge if you label computer science as a foreign language, which first of all, it's not a foreign language, but if you actually call it that, then the other things that get broken are, do you need a language certification as a teacher to teach computer science? And if your students graduate with that as their foreign language, will the university that they apply to recognize coding as their foreign language? We are generally very opposed to that policy at code.org. Computer science is a field of its own, and it deserves its own calling and credit, not pretending that it's a foreign language.
Any other questions?
Hi, I'm Jessica Hooper from Project Lead the Way. I have a question probably for Anthony, but any of you could take it. How are you addressing in Arkansas the teacher capacity issue? And then you mentioned earlier that course codes are not a challenge for you in Arkansas. So how would you recommend departments of ed handle AP versus CTE, or the academic side versus CTE?
So, yes, and thank you, Project Lead the Way. We have a strong network of y'all's system within our state, so I appreciate the work that y'all do. But to the teacher capacity issue, I can tell you one thing that we did early on is I saw the need for statewide trainers that were Arkansas-based educators, Arkansas-based teachers. That way, we didn't just hire somebody to come in for 3 years and then they leave, and then you have attrition issues that happen with a lot of different programs or initiatives that states try to ramp up. So we have hired and have funded 7, and actually we're going to expand to 9 within the next couple months, statewide CS specialists that provide our training to our teachers, and they provide that through our local education authorities. We call them educational service cooperatives, and we provide that to all teachers free of charge across Arkansas. And in fact, we've put stipends behind teachers completing certain levels, and we're actually expanding that. We'll have some announcements next week, so I don't want to steal that thunder. And then to your other question, which was, I'm sorry, other portion of your question?
Course codes.
Course codes. Oh, so just real briefly, there is a white paper that we co-wrote with co.org that's called Rethinking Perkins. And what really happened in Arkansas is there's a gentleman that works at the Arkansas Career Education Department named Tim Johnson. He's bald like me. I don't know what that says. But we just got in a room and locked ourselves in a room for about 12 hours, screamed at each other, hugged it out, and then we came out of the room and we agreed that computer science was no longer going to be a separate subject area in Arkansas. And so we just asked ourselves, what is every problem that we could encounter? I will tell you, most of your CTE programs, and I've talked to a lot of them around the nation, are going to come back and say that they can't do it because of federal Perkins. That is a lie. Don't listen to them. There is nothing in federal Perkins that prohibits it. If there is anything prohibiting it, it's in your state implementation plan of Perkins, which as a state, if you're interested, you can change. So getting 2 bald guys in a room and yelling at each other for 12 hours and your problems are solved.
Question.
Aloha. My name is Kai. I'm a state senator for Hawaii, chair of the Higher Education Committee and vice chair of the Education Committee. So P through 20 education, especially in Hawaii's public school system, has got my hands in that every single day. First of all, thank you for the code.org website and the link you just talked about to the individual states and many of the policy suggestions specifically for the state of Hawaii, I completely agree with, and we're working on, and will work on in the 2018 legislative session. My question is not directly tied to coding, but to get your opinion on virtual reality and augmented reality and implementing that into our educational system, and what's your opinion of that in the future, and how that could indirectly tie into computer science and engaging students in these types of learning methodologies, and what you think the future of that holds. Thank you.
Sure, my view on that is every 5 years there's going to be a new technology. It's going to be hard for the school system to pick every one of them. And it's also, if it involves buying new devices, it may be expensive. It's not clear whether virtual reality or augmented reality are going to be something that every one of us uses the way we use smartphones, or whether it'll be something that's used in a sort of lesser basis. I think the most important skill we can teach students isn't individual computing skills, but simply the learning ability to adapt to changing technology. Because whatever they're going to leave high school with, it's going to be different in 10 years and different again. And so the ability to adapt is the most important thing. Right now, I think augmented reality and virtual reality are more fun as just a way to make it sort of provide a little spark of inspiration. Oh, it's kind of cool, not as an actual thing that you'd want a deep course in at the high school level. Or if there's a deep course, that's for a very small number of the students. But it's a great way to build excitement around computing just because it's cool and different.
Thank you, everyone, for the leadership that you show in your area of influence. Please help me thank our panel for a great job.